So instead of letting you go early, money's worth. So this is a good review of addition reactions to alkene. So what do you suppose the product is going to be? Oh, I got horrible reflection. Here is a carbocation intermediate. And what are carbocations known to do? What? Eliminate hydrogen and form an alkene. That's not going to go back to the product. Let's do something else. And so this is going to be a hydride. Oh, more editing. Yeah, a methyl shift. And then eventually, we won't do the whole mechanism. So generally on a quiz, I wouldn't necessarily do this. I'd probably go try to... And perhaps, maybe I should have done this one in all three spots. We'll come back and do that. So we could think about the intermediate one I wanted to do. Let me change it up, and we can imagine the acetate hanging on there. All right, this will be a better example problem. So as up above, if I can realize this thing is going to rearrange, I don't necessarily need to draw the full mechanism or the intermediate. And here, it stops any rearrangements from occurring. We wouldn't have any rearrangements. Maybe what we want to see. All right, so here on this carbon, I'm gonna draw a wedge and a dashed wedge. In fact, where do I want to draw the black hydrogen and where do I want to draw the red? This would be the stereochemistry. Alright, so it's Markovnikov regioselectivity. The rich got richer and the hydroxide went to the more substitute carbon. Notice now I have hydrogen and OH on opposite sides of the ring, and that's due to the anti-addition. So, what do you know about the boron reaction? Everybody shout it out at once. Alright, presently those look like methyl groups, but so if it's anti-Mark, well, first let me put the methyl group here in the same spot as this other one. So what means has to go here? Yep. So yes, it's anti-Mark, so we'll put the hydrogen there. Alright, so there was previously there's a hydrogen here, right? Where do I want to put it here? Yeah, going down behind the plane of the board, I want to put it on the dashed line. Alright, so here we see the spin addition nature that the new groups are on the same face of the ring. Here we see the anti-addition nature because things added are on opposite sides of the ring. Halohydrin. Halohydrin. What's a halohydrin? Stuff we went over yesterday. Yeah, OH and a halogen. So maybe here I'll write a intermediate, and I'll try and be hard back. So where does that water want to hit? I should have drew it up. I should have drew that a little more rotated. Well, we're gonna rotate it now to please everybody. Might be vision. You know, this ring is kind of straining things a little bit, and I'm gonna go ahead and color code. So if we imagine a chlorine to be like a hydrogen, we can say it's Markovnikov regioselectivity, and we say it's an anti-addition stereo. Chlorine and the OH are on opposite sides of the ring, and so this OH wants to hit this carbon. Other than that carbon, due to the transition state, a positive charge develops on a carbon. It's better if the transition state will be at a lower energy if the partial positive charge is on a carbon that's more substitute. This carbon's more substitute than that carbon. So the electrons jump onto the chlorine, and so this thing's already up. It stays up, and this thing hits from the back side and pushes that CH3 up like that. So how many of these have enantiomers that form also? Does this one have an enantiomer? No, I don't have any asymmetric carbon. So on Monday, we will look at peroxides. No, I have it ready to hand out.